So good afternoon. The Rise of the Thinking Machines is the title of this panel. And when I read that, I thought, oh, okay, that sounds the rise of something. It's kind of maybe a little bit threatening. So I'm actually hoping we're going to have a good discussion today. And I'm very happy to welcome the three participants. Starting on the right, Chris Biemann. Chris is a professor at the Technical University of Darmstadt. And he is working on, let's say, on linguistics and cognitive computing, automatic ontology detection, that kind of thing. So to translate it into popular culture, he's maybe working on C3PO. Next we have Ozel Christo from the company Neokami. And Neokami come from the, let's say, machine learning in the finance area and security. So continuing the analogy, maybe he's the guy who's going to be building Skynet. Nobody knew. No, does anybody know what Skynet is? No. Okay. Anyway, some of you know. You can explain it to the rest. And then on my right, Professor Raul Rojas from the Free University in Berlin. I'm very happy to welcome you. And his specialization he's a professor for artificial intelligence. His specialization is in robotics, autonomous robotics, football-playing robots, self-flying robots, that kind of thing. So I was a bit stuck as to how to continue the analogy, but maybe he's working on R2-D2, but we'll see anyway. We have not very much time, 27 minutes, and I'm going to ask the panelists some questions, and I hope we're going to have an interesting discussion. I'd like to open with from my own point of view, a provocative assertion is that cognitive systems, from my point of view, are still tools. They are maybe much more sophisticated than a hammer, but they're still tools. But there is another school of thought which goes in the direction which says that cognitive systems are on the way to becoming our peers, in some sense. So I'd be very interested in each of your takes on that. And let's start with Chris.
Yeah, thank you, Mark. So are they tools or are they peers? I think they are tools and they stay tools. They are clearly meant to be tools because this is our decision on how we're going to use this system. And what are systems for? Systems are for helping us performing tasks better, for improving our lives. And they can't be peers, in my opinion, just because, they're not biological, they don't sexually reproduce, and they don't do a lot of other stuff that we do. So I couldn't possibly imagine viewing these systems as equals, even though their cognitive capabilities might be as good as ours or might even extend ours.
Yep, let's go.
I think that currently they're tools. However, the question is more a question of human behavior. Because the difference between tools and peers are really how we interact with them. So if you take, for example, a dumb phone from the early 90s, this would definitely be a tool. But now we have smartphones with a bunch of apps. We wouldn't necessarily call it a tool anymore. It's almost closer to a companion. It's definitely something that we can't live without. And if you take another example with a biological example, a baby is a companion. However, evolutionarily, it's a tool for passing on your genetics. So, I think that the line is very blurred between what a tool is and what a peer is. It really depends on how we interact with that makes a distinction.
I was right with Skynet. Okay, well.
Okay, I have been working on artificial intelligence for the last 30 years, and I have always thought about the machines that we build, the machines that we program, and the robots that we build actually as tools. So we even build humanoid robots that can play soccer, or now we are building autonomous cars. And the best definition for an autonomous car is that it's a taxi, so you just get into the car and the car takes you where you want to go. But I think that the people who use these robots and the people who use these cars, they are aware that they don't have any kind of cognitive ability at the level that we expect from a peer. So that from the point of view of the user, from the point of view also of the developers, these machines are just tools, are just a way of getting things done, and I don't expect them to be competitive with humans within this century.
Within this century. Okay, that's an interesting and clear statement. Most of that I would agree with. The burning question, of course, is what would have to happen to change that? We can talk about that later. Ozel, I want to go to you now. Since you're among the panelists, the one who has the direct experience with founding a company, running a company, and I'd be very interested to know how you see cognitive systems changing we heard about it earlier, B2C, B2B, but not just the consumption side of things, but also the way we work, the way we interact. So how are cognitive systems going to change that?
Yeah, it's a good question. I think what we're seeing right now is the market's extremely early. And so with a lot of early markets, a lot of the initial customers are very service-led, use case-led. Where I'd like to see it go is that artificial intelligence is not just a commodity for tech people in Berlin, as somebody had mentioned, but really something that everyone's using because it can actually be applied in so many ways, as everyone here can say. One of my main observations would be that algorithms themselves aren't that special anymore because, especially with IBM Watson and other players, algorithms are becoming increasingly a commodity. And I think what we need to see are proprietary and growing data sets to actually produce consumer apps that are of value. Because if you take an open source data set and an open source algorithm, there's actually nothing proprietary in that application.
Okay, so I mean it's an interesting take because especially in Germany there's a lot of momentum behind the open data movement. So you see that as a hindrance or as
No, I think that's really good because algorithms are improved by open data sets like MNIST, where you can MNIST is basically like fruit flies for a biologist is MNIST to a data scientist. You constantly iterate and see how good your algorithms can get on the same data set, but in order to actually, you wouldn't make an application with MNIST because it's just open, you wouldn't want to sell it, you can't actually commercialize that. So actually to have something commercial, I think you need to have a proprietary data set, and the only way to actually accomplish that is to get the user to somehow auto-label a data set without really knowing. So Google's very good at that, right? So every time you search for something, it's a labeled data point. And at Neokami, we're trying to create applications that somehow leverage the consumer into, let's say, a prosumer of AI, helping the algorithms almost as a peer or a companion to help it get smarter. I'm the kind of guy where when I go on Netflix, I spend almost an hour just rating movies because I want to help the algorithms. You know what I mean? I already consider them peers in a sense.
I won't confess what application I use to spend hours improving. No, it's not online dating. Chris, when I look to Japan and what's happening in Japan with robotics, then there are robots which are being used in an elderly care setting, robots being used in a sales setting. My colleagues with Watson, I think they're also working on this. And the idea here is to somehow establish an emotional bond, because emotion sells, but emotion also, as you almost certainly know, in medicine, feeling good, establishing trust also helps the chance of you getting cured. So there are systems out there which, and I would say, mimic emotion. Other people would say they have emotional intelligence. So my question is, do you see a difference there? What is the difference? Can we think about emotional robots, or is it something completely different?
Well, you have to distinguish whether there's a difference from the interaction or there's a difference inside of the system. Right? To give you an example, just when we talk, I don't even know whether you have emotions or not. I can just, act as such, but maybe you don't. You just pretend to have emotions, and I can really not say that. I can't probably even know whether I have emotions or whether this is just a chemical reaction. But of course, you want to have your system's emotions, you want your systems to have feelings, or at least pretend to have feelings in certain situations, as the one you mentioned. In other situations, you probably don't want them to have emotion. Think about, we talked about tools earlier. So if I have a problem, I want to put a nail on the wall, and I get the hammer from my toolbox, but the hammer tells me, today I got a headache, please don't, use me for that. You don't want to have that, right? So it's still for a purpose, it's still for a tool. So I don't think that these machines have emotions. I don't think they should have emotions. However, they should accommodate our emotions for interaction.
Okay, I mean, you've hit on a point there, which I think is actually key, is that when we talk about cognitive systems, we talk about primarily, not exclusively, but primarily about a linguistic interaction.
Yeah.
Obviously, there's work going on at places like MIT, also in, I think in Tokyo, on embodied interaction, because depending on which culture we're talking about, I mean, you can see my hands are moving around here. I'm British, so we move our hands a little bit. If I was Italian, they'd be moving a lot more. If I was... I didn't want to say that. I didn't want to say I don't want to embarrass you all. I don't want to out you. But if I was from another culture, I would be just standing here. And that's obviously a key aspect, which we're probably not capturing or not including in the cognitive world as much as we should do. Raul, how do you see that?
Well, let me go back to the problem of emotions, because I think that's a very important discussion, and it's a discussion that neurobiologists have been having in the last 20 years. So the question is, can you have intelligence without emotions? Can you have a purely rational intelligence that's not feeling anything? And for example, Damasio, a famous neurobiologist, he has the opinion that the world is too difficult, too complex, and whenever we take a decision, we don't just take a rational decision, we also take an emotional decision. And emotions are a way of selecting among the different possibilities, so that you don't have 1,000 cases, you only have 2 or 3 cases where you want to decide. So emotions are an essential part of intelligence. That's what Damasio says. Now, people doing robotics have tried for many years to think about that, to try to figure out how could robots have emotions. Do we need robots with emotions? And I'm really of the opinion that robots cannot feel anything. Robots will never have emotions. It will never be like in the science fiction movies, like for example in 2001, Space Odyssey, where the robot is being disconnected and it fears for its life because it's losing its rationality. So I think a robot, a machine cannot a machine is fearless because it can always be copied. You can always clone a machine. You just copy the memory and then the machine is in another place. So I think that real emotions presuppose fear of something, fear of dying, fear of illness. And machines will never have fear of anything, so machines will never have emotions.
Okay, I mean in Matrix, of course, Can
I add something to that and ask you a question? Because this is something that has puzzled me for quite a while now. So is this connected to reproduction and life? I mean, people like Darwin, Dawkins, and so on, they say, simply because we're here because we're motivated to live and reproduce, otherwise we wouldn't be here anymore. And there's where the fear of non-existence comes in. So would you think in the future, if we had reproducible, self-reproducing robots, so to say, that a fear of non-existence would come into place?
No, that's what I'm saying. A robot cannot be afraid of anything. What if you were a robot? Would you be afraid of dying crossing the street? No, because maybe you have a copy of yourself somewhere else. Would you be afraid of losing an arm? You wouldn't be afraid. Would you know what sadness is? you wouldn't know what sadness means, even if you can simulate that you are sad for a person. That's why I think that using robots in healthcare, saying that in the future, elderly people are going to be living in hospitals, and the robots are going to be taking care of these elderly people, that's for me a horror scenario.
But that's actually, I referred to the Japanese culture before. In Japan, they've actually, there are robots which mimic facial expressions, emotions through facial expressions with elderly people, and the results are, I mean, they're not, it's not like the best thing since sliced bread, but it definitely has a positive impact on the well-being of those people. So that's what I meant with, true emotional intelligence, or just something which mimics it. So it seems that for humans, that just the expression of the behavior of feelings is enough to elicit an emotional reaction in us. Ozel, how do you feel about that?
Yeah, I think it goes back to the first question you asked, and I think it really is a human behavior problem. For example, when I was a kid, I would relay emotions into a rock, right? If I wanted to have a pet rock, then this rock would have feelings. That's an extreme example, but I also think that, when we talk about personal robotics and AI, now, don't get me wrong, I also agree that I don't think that machine learning algorithms or robots with machine learning algorithms could actually have truly emotion, but I think that they can definitely evoke an emotional response. Imagine a machine learning algorithm in a cute puppy seal robot. Or how about the video we just saw with IBM Watson and the child interacting with, by speech with the IBM Watson? That's definitely an emotional response. You can see the emotion on the child's face. So to answer the question, I feel that on the robot side, the AI side, probably not. I don't want to say no, because usually scientists who say no are always disproven sometime in the future. So I don't want to say no, but I don't see how that's really possible mathematically. But certainly on the human side, I think there's going to be a lot of emotion evoked, especially in the personal robotics space.
Okay. Well, let's take that thought one step further. If I look at machine learning, cognitive systems, AI, whatever you want to call it, then I think we agree these are tools, more or less. And the thing about tools is we design them for a specific purpose. We always discover new uses. That's our human nature, Notwithstanding, if you have a hammer in your hand, everything's a nail. But if you have a machine learning algorithm in your hand, then everything becomes a data problem. So what puzzles me is if I look at the way we as humans actually innovate, then very often it's not about doing the same thing with the same tools, but it's about breaking the paradigm. It's the guy who's sitting in his garage. Nobody's paying attention to him. Everybody's calling him a crazy guy because what he's doing just doesn't make sense. And then he comes up with something really new. So I would be interested to hear your opinion on what would have to happen to make that possible with cognitive systems. So, Raul, do you want to start?
Yeah, but the quick answer is nobody knows. I mean, for example, Roger Penrose, he writes about exactly this problem in his book about artificial intelligence. And he's of the opinion that computers nowadays, they don't have the power to express creativity. And then he goes on to suggest that maybe the brain itself, it's a quantum computer, so that using a quantum computer, you can go out of the space of possibilities, examine all possibilities at once, and then take a decision. So I'm not saying that this is the solution. I'm saying nobody knows how to do that jump from plain execution of algorithms to creativity and breaking out of the box.
Okay. What about you? What do you think?
Yeah, I think this really hits on the key of what is the definition of disruption? And I think disruption is when that guy in the garage, he focuses on a couple of dimensions that are important to a couple of people and sacrifices a lot of dimensions that are important to most people, right? So that's sort of a general definition of disruption. And so I think in the context of AI, the only way that could really happen, maybe like intuitively you would think that you just have an amazing algorithm that finally can mimic human intelligence. And I think that's kind of the case, but I don't think it's through the algorithm itself, I think it's through the data. So I think the truly disruptive force in AI will be the faster flow of proprietary data with higher calibrations from multiple sources, which is basically the definition of IoT.
Okay, Chris?
Yeah, maybe let's bring in a different angle to that, because I don't think it's so impossible. And what this reminds me of is something that I, as a language technology, do sometimes, which is finding metaphorical use in language. Right? What you do if you want to find metaphors, you first have to know what is the usual way language is used, and then you find where this is violated. And this is basically how you find needle in the haystack. And for this, of course, first you have to know what's the normal. This is covered by big data. And the interesting part about the cognitive systems is that you can actually train your cognitive system to find these kind of disruptions. I'm not so sure about the creativity part of it, but of course you can make a system generate likely connections. And as far as I remember, they actually did this with Watson at some point. They had the Watson recipe book where they combined weird things together and they cooked them and then they tried them. And actually half of them were terrible, but there were really interesting recipes coming out of that, of the ones that were actually tasty. And this is what we have to expect here. And nobody can expect a machine to come up with the next disruptive technology in a high precision. Okay, this is going to be the one. This is not, how it works. How does it work? We have 1,000 companies thinking they have something disruptive. One survives. And we're going to have the same thing here. And I don't see why we can get a rate of 0.1% with cognitive computers as well.
So maybe the cognitive systems will improve our hit rate on what works.
Yeah,
so,
may I say just a short comment. So Rodney Brooks at MIT, he's of the opinion that you cannot have an algorithm that can think or can do everything. He says what you can do is you can build a computer with a body, that means a robot, and then you send that robot into the world, and the robot learns by doing. So learning by doing is the key to intelligence, according to Rodney Brooks. So you may agree with that or not, but I think that's a very profound point. So you cannot design an intelligence from A to C just by sitting on your desk and writing the code. It has to develop by itself.
I would, that's my own very personal opinion, is that embodiment, the whole thing about embodiment, is absolutely key to building intelligent systems. And as you said, Rodney Brooks is a pioneer there. There are a number of others, but I think that's key. So we have just over 3 minutes left, and I have one final question for each of you. And this is your chance to do a little bit of Eigenwerbung, a little bit of self-publicity. So what are the significant steps you think are going to happen in the next 5 years in cognitive systems? So why don't you start, since we, yeah?
Sure. I think there's two planes to consider, the data side and the application side. If I have to make a plug, I guess it's the time, so I guess we're on the application side, and that would be bridging the gap between non-tech first enterprises into AI. So enterprises, telecom, financial services, government, and having basically AI be a staple, whether that's more of a time series analytics use case, customer service use case. Already we have customer service agents that are like a hybrid between human and AI. So an AI will talk to you about normal things. If it gets really weird, a human will jump in, then it'll go back to robotic voice. I think we're going to see a lot more of that across a lot more industries. And that's kind of the area that we're focused in on Neokami. The other side is the data side. And as I mentioned earlier, IoT. I really think that IoT and this infusion of more sources of data is what's really going to fuel the AI revolution, if you want to call it that. So data from connected cars, personal robots, drones, smart offices, which is a project we're working on right now. This new data is really going to help us, I would say, propel us into the future.
Okay. Raul?
Yeah, I think that in the next few years we will have encyclopedic databases. So we already have Wikipedia and we have Watson and we have programs that can summarize that information. I think the next big step is to have inference on that data so that you can ask questions that are not included in the data and generate new answers from those inference systems.
Okay. I know, Chris, you're working on exactly that, and you're...
thank you for this nice thematic
So why don't you
introduction.
close?
Yeah, so I personally think the key to this is interaction, because a cognitive system learns by user interaction. So we have to take the user where the user stands and make the user use the system and tell the user, okay, if you use the system will improve, and you don't have to sit there for 1 hour labeling movies, but you just do this on the side. So how do we engage users? And maybe I'm saying this because I work in this field, but I think key to this is natural language interaction as well as other modalities. But natural language is maybe the most natural interaction. We communicate with each other, so we might also communicate with this kind of system. And natural language has 2 roles here. One is just the access to information and the communication. But natural language is also subject to personalization. Now, I don't want to have this same predefined dialogues all the time. I don't want to learn what are the keywords that my system reacts to. I want to self-define these keywords. I want to customize my software. I want to customize the interface itself, be it language, be it other interfaces. So I think this is something we profoundly have to solve in order to bring cognitive computing to mainstream. Thank you.
Okay, well, I think the time is up, so we're perfect point landing, as they say in German. I want to thank Ozel, Raul, Chris for your thoughts on the questions. I hope the questions I asked and the discussion we had here was interesting for everybody. Thank you for your attention, your time, and yeah, maybe we can look forward to a future with embodied, hybridized, interactive tools. Thank you very much.
Thank you.